In this video, we'll be answering this question based on torque. So the question reads, it says a solid uniform frictionless cylindrical reel of mass, which is 3.00 kg, and the radius, which is 0.400 meters, is used to draw water from a well, as seen in the figure below. So as we can see here, which is this figure here, this is the well which is used to what, to draw water. Okay, now they are saying that a bucket of mass, which is this bucket here, a bucket of mass 2.0 kg is attached to a cord that is wrapped around the cylinder. And the first question says, find the tension in the cord and the acceleration of the bucket. So what we are doing now, we'll find the tension which is in this cord and also the acceleration at which the bucket is moving. Now, for us to deal with this type of the question, what are we supposed to do? Now, let's look at the things that you have been given. So the things that you've been given, we have A here, then we have B here, and you have also C here. So in this situation, this A, they're just showing us how the water is being what? The water, how we're getting the water from the well. But when you go to B, if you look at B, where there's B there, this is the free body diagram that is on the bucket, or B is telling us or showing us the forces that are acting upon the bucket. That is B. Now, when you go to C, so on C here, it is telling us how the cylindrical reel, how is it moving. So those are the main things that are showing us. Okay, now let's look at how we solve this type of the question. Now go to the free body diagram, which is B here. So on this part, if I may ask, how many forces that are acting upon this bucket? So the forces that are acting upon this bucket, we have tension force, which is pointing up. That's the first one. So take this side as my positive side. And what is another one? Another one is a gravity force, which is pointing down. So this means that I have the forces, two forces which are acting upon the bucket. Now for me, how I'm going to do that one, I'm going to say summation of the forces in the y-axis. Why in the y-axis? Because this bucket is moving vertically. So I'll have to say the y-axis. Okay. What are the forces? You have one force here which is acting up. So this is T1, like that. It's pointing to the positive direction. Again, you have the gravitational force which is pointing down here. So I'll say minus what? mg. Now, since in the question they are asking us also to calculate the acceleration, right, of this bucket. So what I'll do is that, since we know that force is equal to mass times the acceleration, so what I'll do is I'll have to say where there's force here, or the summation of the forces that are in the y-axis, I'll say mass times acceleration equal to then T minus what? mg. So this one, it is for B. So let me put for B. Why for B? Because I'm just talking about the what? The bucket. Now let's look at what is the mass of the bucket. So according to the question, they're saying that the mass of a bucket is 2 kg. So wherever there is mass, I'll put 2 here equal to tension minus then here to be 2 times 9.81. So this means to be 2a equal to t minus, when I multiply there, which is 2, which is 2 times 9.81. The answer that you shall get, it is 19.62. So that is your first equation on B here, or the first equation on the what? Bucket. Now, after doing that, I'll go to C. So if I go to C, I will be talking about the cylindrical reel, or the one which is rotating to draw water from the ground. Now, this is the equation 1 for A. This is equation, or this is equation 1 for what? For B, for a bucket. So let me even put here that this is what? Bucket. So I've even indicated that this is what? Bucket. Now let me go to C. What is there on C? On C, you have this part here. On C, you have what we call cylindrical reel. So let me say another equation that I'll have to create, it's what we call cylindrical reel. So I'll do this. This is what I've done. Okay, now since this object here, it is rotating. So if you look, it is rotating in this direction, right? In here, what you need to take note of, the force that is able to rotate an object, it is what we call torque. So since we are also looking at the acceleration, right? So what we'll do, it will be torque is equal to 1 over torque is equal to, sorry for that. So say torque is equal to moment of inertia times the angular acceleration. So why did I put the angular acceleration? Because we are looking for the what? Acceleration in the question. That's why I've put the angular what? Acceleration. Okay, now in here, remember that this object, if you look at C, this object C, it's moving clockwise direction. This, it tells us that this object, it is what? Moving in the clockwise direction, or if it's moving in clockwise direction, meaning that the torque is what? Negative. So I'll put the torque here to be negative, like that. Okay, now after doing that, what is the other thing that you need to do? The other thing that you need to do here is that, what are we calculating? We are calculating the tension and the acceleration. Now remember the equation of torque. Another equation of torque is force times what? Radius. So I'll get this equation, force times radius. Why I'm saying force times radius? Because I'm calculating the tension, so I need to put that one. So even here, the moment of inertia, it will change because I'm calculating the what? The linear acceleration. So remember again, they have said it in the equation that it is what? A solid uniform. So anything which is a solid uniform, meaning that you need to use 1 over 2, then mass times the acceleration, like that, or mass times the radius, like that. So that is what you do. Then times, right? Times what? Angular acceleration. Now, what type of the acceleration are we looking for? We are looking for the acceleration which is a linear. Now let's go back a bit in rotation motion. Remember that acceleration is equal to angular acceleration radius. So where there is angular acceleration here, I need to substitute, right? So meaning that I'll make that one to be the subject of the formula, meaning that angular acceleration is equal to A over what? radius. So this means that where there is force, it is tension. So where there is force, it is tension. I'll put tension there because that's what I'm looking for. So to be negative 1/2, then mass radius times what? Acceleration over radius. So this radius and this radius, they'll cancel. How many t that remain? 1. So I will have something like TR is equal to negative 1/2, then mass times radius A. Now we have radius this side, which is this radius and this radius, they'll cancel. So meaning that we have T equal to negative 1/2, then mass acceleration. Then what will happen? T equal to negative 1/2. Then what is mass? What is mass? The mass of the cylindrical reel, it is 3. So I'll put that. I'll put where there's mass, I'll put 3. Then A. Meaning that my answer to be equal to negative 3/2, then A. So this is my equation 2 for C, for this part here. Now, after doing that, what do? I will get equation 1 and equation 2 so that I can find the tension and the acceleration. Now, what is my equation 1? My equation 1, it is T minus 19.62 equal to 2A. That is my equation 1. And my equation 2 is what? T is equal to negative 3A/2. So this is my equation 1 on top, and my equation 2, it is this one. So as you can see there, that's equation 2. Now, after doing that, what next? We know that T is equal to negative 3A/2. So what I will do is that where there is T in equation 1, I'll substitute with this so that I can find the acceleration. Now, what will happen? It will be T minus 19.62 is equal to 2A. So here I'll substitute with that, which is negative 3A/2 minus 19.62 equal to 2A. Then the next part, it is 19.62 is equal to 2A. Then this part will go to the other side, it will be plus here. Then it will be what? 3A/2. Then from there now, what do you do exactly? So from there now, if you want, you can look for the common denominator, or you can just go direct. Okay, now let me just look for the common denominator. What's the common denominator here? It is 2 here, so meaning that here to be 4A plus 3A. Then what to do? I'll do cross multiply, right? So in here on top, it will be 7, right? So 7 times 1, it will be 7A equal to, so I have to say 19 times, that's 19.62 times 2, meaning that it will be 39.24. Then what next? I'll divide by 7. I'll divide by 7. So meaning that this part, I'll divide, meaning that A is equal to negative. Now I'll divide by 7 there, meaning that A is equal to negative 5.6. That is the A there. So I have found that A, it is negative 5.6. That is A. So let me write it here. A is equal to negative 5.6. 6 meters per second squared. So that is A. Now for me to find B, what I'll do is I'll get this equation 2, which is this part, for me to find the tension now. So what I'll have to say tension is equal to negative 3A over 2. So where there's A there, right, I'll put negative 5.6 over 2. Now, negative times negative, what is the answer? So it will be positive there. Then after dividing, your answer that you get is 8.4. So, in short, my tension, it is 8.40 newtons. So that is how you calculate question A. So I'm done with question A. Now let me go to question B. So how do we answer question B? I'm just creating space here. So how do I answer question B? So on question B, let me even do this. So this is question B. They're saying that if the bucket starts from rest at the top of the well and falls, right? They have even said and falls for 3.0 before hitting the water. How far does it fall? So now, remember, it is going down, meaning that even the acceleration is negative. Yeah, so which is the correct things? It was going down. The acceleration is negative, and meaning that even the displacement that we found here, we shall find it will be negative. So what am I supposed to do? I have to say displacement in the y-axis is equal to, right, VIT, then plus 1 over 2 acceleration times the time. Now remember, this object is started from rest. Since this object is started from rest, meaning it will be 0, what's the time? I've said 3 plus 1 over 2. Then the acceleration that you have found, it was what? It was moving at negative 5.6. Then what's the time? 3 squared. Then your answer will be negative 25.2, which is meters. So that is your answer that they are looking for. So that's how we answer this type of the question if you have been given this type of the question. Okay, make sure guys you subscribe, like, and also comment, share the video. For more details, join District Learning Institute. You can download the app, and you can also subscribe there so that you can learn more, a lot of things from there. Thank you.